Okay, so now if we look at factoring a quadratic with leading coefficient greater than 1, then we're going to find this to be a little more complex, but not much different than when we have a coefficient of 1. So we know our answer is going to look like this. And in this case, instead of knowing that it's like a w times a w or an x times an x, we've got this 5w squared. So if we come down here and we take a look here, then we know that in this case it's got to be a 1w and a 5w. So it's again pretty simple in that we only have one option, but it's just not 1 and 1. So what does that do? Well, it just makes it a little more complex when we get to the second part. So remember, we want to double check with the FOIL method. Our first is going to give that 5w squared. Then what we really need to pay attention to is our outer and our inner. The outer and the inner always combine because they're always going to be like terms. And in this case, what that gives us is it's going to give us a p plus, it's a q plus 5p times w. So that q plus 5p has to make up that 32. That's where this comes from. We know that we have to multiply. The last terms have to give us the 12, of course, right? P times q, that's our last. That has to be 12. But the outer and the inner makes that p plus 5, q plus 5p, and that has to give us the positive 32. Right? So that's what we got to think about, and then we can set up our little t-chart like this. So we've got the p and the q, which are the two factors of 12. So p and q have to make 12 when they multiply. And then here, the q plus 5p, we're looking for 32. So let's just check. Let's check 1 and 12. 1 times 12 is 12. And if we multiply the p times 5, that's 5, and then add the q, that's 5 plus 12, that makes 17. So we can mark that one off. That doesn't work because it doesn't give 32. If we switch 12 and 1, then we get a much different answer. We get 61. So if you do the calculation, 12 is the p times 5, so that makes 60 plus the 1, that's 61. That's not 32, so we can cross that off. So we're just going down the list. We have 1 and 12, 12 and 1. What else makes 12 when we multiply? 2 and 6. If we put it together in this order, we get 16. That doesn't work. But if we switch the order, see, that's where you have to be careful. Make sure you do both directions, 6 and 2, then that does give us 32. And that then allows us to come up with our final answer of 1w plus 6 times 5w plus 2. Let's check. We always want to double check. We get a 5w squared for our first. Our outer is a 2w, and our inner is a 30w. Those combine to make 32w, and then our last is 12. That's what we started with, so check. That makes this the right answer. Alright, one more example. So here we are factoring the 3w squared plus 17w plus 24. So we know we've got two binomials, and in this case we know it's going to be a 1w and a 3w. You could also set it up to be a 3w and a 1w. It doesn't matter. You just have to keep track of what's what. If we have our plus, if our pattern 1w plus p times 3w plus q, our outer and our inner here, outer and inner, is going to be q times w plus a 3p. So we set up our t-chart like this. we say P and Q, and then Q plus 3P. Okay, so let's check. The P and Q has to be 24. So what can we do? Let's try, I don't know, 3 and 8. That's the first thing that comes to my mind. And they're both positive. So if the P is 3 times 3, that's 9, and 8. What do you know? I nailed it the first time. It gets 17. Bingo. So that's our answer. So it's going to be a 1W plus 3 and a 3W plus 8. Done. Foil it to double check.